Mr. Rulani. Today I'm going to be discussing the project that I've done. The project name is upgrading the road D885 from gravel to a standard surface two-lane or two-way road. This project is currently in Limpopo. So going to be upgrading the project, the road to make it two-lane or two-way in Limpopo province. Okay, the second page of the slide, it will be covering the introduction of the project, which is project of the road D885. It's situated between the small township or semi-rural areas of Puring and Mahlareng in the Limpopo province of South Africa. The settlements are not located near national roads, but they are instead connected by provincial road or a district road with their traffic ultimately feeding into the main road. The main road is D3600. Road D885 forms a T-junction with the main D3600 road, allowing traffic to be distributed to various destinations as well as major towns such as Leboa and Polokwane. We move to the next slides. Assessment of the road condition. The existing road has been graded along natural ground levels and shows significant deterioration, including severe deformation and block cracking. Certain sections contain clayish or muddy material, which then can result in slippery condition. Rock outcrops are also not present on that road. The estimated plasticity index, PI, is very low, and the maximum stone size ranges between 25 to 50 millimeter. The proposed road layer consists of thickness between 25 to 50 millimeter. The subgrade quality is considered to be moderate. Moving on. So on this one, we're gonna be discussing about the CSV survey data, which was collected or gathered on a site after the initial visual assessment. To begin the design process, it is necessary to determine the boundary condition of that area. The collected data will then be imported into Civil 3D to generate geometric alignment and assembly of that road. Move to the next slides. Here on the next slides, it shows the software that I will be using, which is the Civil 3D. Moving to the next slides. The following slides shows a geometric design which will be applied during the design of or the construction of the road. The geometric design will consist of sidewalks, pavilion lane, which are both or two lanes, which are indicated on the first slides. It will also include the sidewalks where people will be moving around. So most of the stormwater will be 1 meter deep. Sanitary sewer or sanitation and sewer, the depth of the sewer line or a sanitary sewer will be 1.5 on the project. The water main or the water pipe will be 1.5 meter deep on the side of the road. Moving to the next slide. Here we're gonna be talking about the pavement design. Pavement design, it consists of a carriage and a walkway structures. So I'm gonna start with the carriage walkway structure. Here we're gonna be focusing on the different type of courses which are we can find in a pavement design. The first one will be we're gonna be focusing on the wearing course, which is 50 or 40 millimeter, which is made of asphalt concrete. We're gonna be designing the binder course, which is made of 50 millimeter, made of asphaltic concrete. After that one is gonna be followed by lateritic crushed rock base, which is 250 millimeters. The second layer will be the sub base, which is gonna be 100 millimeters above the first and the second base. And then the last one is the existing subgrade or embankment that will be constructed on our road. So when we talk about the pavement design of the walkways, here will be having a double surface dressing on 50 millimeter crushed rock base or a filling material. Yeah, we move on to the next structure, slides. The following slide that I'm gonna discuss with you is the drainage design. Our road will consist of 2% of slope so that whenever floods or wastewater, they can actually be drained on the trench drain. The road will be allocated drains on both sides of or at the edges of the roads. The drainage layer will control all the storm water that will be on the surface of the road. Moving on to the last slides, the next slides. Discussion, the upgrade of Road D885 addresses a critical infrastructure need in the Kuring and Mahlaring semi-rural communities. Currently, the road serves as a vital link to the main D3600 road, which provides access to major economic centers, which includes Lebochum and Polokwane. The existing gravel roads deteriorated condition poses significant challenges to transport efficiency, safety, and economic development in these areas. Moving to the conclusions of the slides. The conclusion is that the proposed upgrade of Road D885 from gravel to standard surface two-lane or two-way road present a significant infrastructure improvement for the Kuring and Mahlaring communities in Limpopo province. Through comprehensive site assessment, survey data collection, and the application of civil 3D software from Autodesk, this project has demonstrated that the existing road infrastructure shows a severe deterioration with significant deformation and block crickling, necessitating urgent rehabilitation. The subgrade quality has been assessed as a moderate, with plasticity index value indicating suitable condition for road construction. The geometric design, pavement structure design, and drainage system design have been developed to meet standard specification for two-lane or two-way route. The upgraded route will improve connectivity between the semi-rural settlement and major roads, particularly the D3600, facilitating better access to Lebogomo and Polokwane. This infrastructure development will enhance transportation efficiency, promote economic growth, and improvement quality of life for residents in these communities. The implementation of the project will address current safety concerns associated with deteriorated gravel road and provide a durable or all-weather transportation solution. Move on to the next slides. Acknowledgement. Here, I would like to acknowledge to express my sincere gratitude to the following individual and organization who contributed to the successful completion of the project. My supervisor, my mentor, and the Department of Civil Engineering for the guidance and support throughout this project. The local community members of Kurung and Mahlering for their cooperative during the site survey and data collection. The Limpopo Provincial Department of Public Works, Roads and Infrastructure providing access to project site and relevant documentation. My fellow students and my colleagues for their valuable input and constructive feedback. Then move on to the last slide. The last slide is all about the references I used to do my project. And the first one will be the Community of Land Transport Official, which is called 2020. I also use the standard specification for road and bridge works for state road authorities. I also use TRH4 for structural design of flexible pavement for inter-urban and rural roads. I also use the South African National Road Agency, SANRAL, for pavement engineering manuals, which is also SAPEM. I also utilize AutoCAD for Civil 3D, which helped me to design the pavement, drainage, yeah, all the designs that I incorporated on the report. I think that's it from me. Thank you for the time. Thank you.